So now it's time to demonstrate backward selection method using a practical real world example. So here what we are gonna do is we'll be doing feature selection in credit risk assessment using backward selection, and here is your step-by-step process for performing credit risk assessment using backward selection for feature selection. So let's begin with our first step, which is load the data and import libraries. So load the dataset which containing various credit related variables such as age, employment years, and default status, and many more. In addition to that, we have to import the required libraries, and let's look into that. So let's import the libraries first, then we will load the data set. So import numpy as np, and the most important sklearn model selection. We are going to import train test plate. So sklearn is your library, model underscore selection is your package in it, and then train test plate is your module. Then we have sklearn dot linear model, so linear underscore model. sklearn library linear underscore model is your package. From that package we will be calling up, we will be importing up logistic regression module. So our backward selection method is going to use logistic regression algorithm to basically do the modeling, and after that it will use an accuracy score, a metric, evaluation metric from sklearn library and metrics package. It's going to import accuracy score, so we will be using this accuracy score for evaluating the best uh, uh, to evaluate the best feature out of the existing total features. And then final one is sequential feature selector. So this is what is going to make everything possible. So that way we'll be importing from library called mlx stand and the features underscore selection package, and the module is sequential feature selector. So now let's load the dataset. So obviously we'll be using read underscore CSV function from the pandas libraries, and the dataset is credits.csv. And if you want to see how the dataset look like, let me go up. Let me scroll down completely here, and let me say D. Okay, just a minute. It's DF. Yeah, this is our dataset. So this consists of 1, 2, 3, 4, 5, 6, 7, 8. One is 8 columns. Out of that, default we will take it as a target variables, and other than that we have, I think, 7. So let's look into the each type of data. Let's have a quick data story. I call this as a data story. Data story is nothing but it's gonna tell the story of the data set that you have. So age in years, this column represents the age of the individual in years. So age can be an important factor in credit risk assessment, as it may indicate financial stability and responsibility. So then we have employment years. So this column, employment years, represents the number of years the individual has been employed. Longer employment tenure may indicate job stability and a higher ability to repay loans. Then we have income, which is in dollars. So this income column represents the individual income in dollars. Income is a crucial factor in credit risk assessment, as it determines the individual's capacity to repay debts. Then we have debt in dollar. So this column or debt column represents the amount of debt the individual currently owes. So debt levels are important to assess the individual's current financial obligations and their ability to take on additional debt. So then we have the credit score. So credit score uh, column represents the credit score of the individual. So credit scores provide a measure of the individual's credit worthiness and the likelihood of defaulting on loans. So then what we have is a loan amount. So loan amount column represents the amount of the loan requested by the individual. The loan amount is relevant to assess the risk associated with granting the requested credit, and then interest rate. The next is interest rate. Interest rate column represents the interest rate assigned to the loan. The interest rate determines the cost of borrowing and can affect the individual's ability to repay the loan. Then the last column that we have here is default. So this column represents whether the individual has defaulted on a loan which is 1 or not, which is 0. So it serves as the target variable for us. It's very important to be remembered at this moment itself. This default is gonna serve as a target variable to us, and for credit risk assessment, indicating that credit worthiness and repayment behavior of the individual. So the data set provides a simulated no the data set provides a representation of various factors related to credit risk assessment. So these features can be used to train predictive models to assess the likelihood of default and make informed decisions in credit risk management. So that's what all about our data, and this is end of the story or data story. Now step 2 is to is nothing but the data processing. Here we won't be doing much because here our main focus is to work on backward selection, not a pre-processing. Of course, it's part of that. So prepare the data by handling missing values, encoding categorical variables if any, and scaling the numerical features as if required. And many of the things we have discussed so far. If not, we'll be discussing in future. You don't need to worry. Next, let's move on to the third step, which is split the data. Split the data. So split the data set into features which is nothing but which are nothing but independent variables, and the target variable its default status. So the features will be used for feature selection, and the target variable will be used for model evaluation. Obviously the features is for the feature engineering, and the target variable is mainly be used for model evaluation. So now let's look into this step. So how to split them, split this data set into um, groups, respective groups. So the next step is basically split the data into features and target variables. So X, and this is our feature. Let me show you here. This is let me execute X and all. So other than default, age, employment years, income, debt, credit score, loan amount, everything, interest rate, everything are X. Those are our features. And now let's see a target variable. So this is our target variable 100010010101. So it's whether he got defaulted or not. That's it. This is our target variable. Why your default status, the default, which is nothing but the status, that's our target variable, and other than that, rest all our features. Okay, now let's move ahead to the most important steps, which is step. Okay, in addition to that, we have to discuss about the train test split of that data that we haven't covered up. So here, if you see, after that x and y were decided features and target variable, now it's time to divide the data into train test split. For that, I'm gonna go with 80 percentage for training and 20 percentage for testing. That's more than enough for this feature selection. So x underscore train, x underscore test, y underscore train, y underscore test. So total four reference variables, and then I'll be calling up instantiating train test split object, and I'm gonna give respective arguments. So capital X is our first argument, small y is our next argument. Then test size, I'm gonna go with 0.2. That means my 80 percentage of data I can use it for training, and I'm gonna give you a random state of 42, which fundamentally mean no, it's a random seed. The same result will be repeated every time that you execute. The same result which is gonna randomly generated by random state 42. Okay, so now let's move on to the very important step, which is step 4, perform backward selection. So it's all done, all set. It's time to perform backward selection. So utilize the backward selection method from a library to perform feature selection. So the library will handle the iterative process of removing one feature at a time, and one feature at a time, based on a chosen evaluation criteria. So that evaluation criteria could be p-value or model performance, or anything else. Okay, so that's what it's the beginning of backward selection. So let's just call up the respective module. So MLX tend is our library, and feature underscore selection is our package, and sequential feature selector is our module where I can use backward selection. Okay. Next step 5, fit the model. So fit the model. Fit a classification model using the selected subset of features obtained from the backward selection. So use a suitable classification algorithm such as logistic regression, decision tree, or a random forest. So you can go with either logistic regression or decision tree or a random forest based on your requirement and based on the type of data that you're working on and based on your problem statement, and based on the result that you're expecting. So that's what is now fitting the model, and let's do that. Let's fit it. So let's fit the model, and then let's instantiate, let's start the backward selection also. So let's initialize the logistic regression model, and that you can see model is equals to logistic regression, and then open and closed parentheses, which also mean we are instantiating the logistic regression class object, and that object can be used a part of sequential feature selector object. Okay, so now once the model has been created, the object has been created, now it's time to perform the backward selection using sequential feature selector. So the name, the reference variable name that I have given for that sequential feature selector object is just a selector, and then sequential feature selector class has been called up, and the first argument is model. So model, this is the estimator or model object used to evaluate the subsets of features. In the example code, it's set as the logistic regression. In this example, we have set a logistic regression, indicating that logistic regression will be used as the underlying model. Then we have the forward. So once you're done, the second argument that we have here is k features here. So this is the parameter determines the number of features to select. It can be different values. If set to integer value, it specifies the exact number of features to select. If set to best, it select the best performing subset of features based on the specified evaluation criteria. So that's the reason, in spite of you giving your customized number, I just put it best, and let's see how many variables it's gonna give, whether all our features are actually makes more sense, or actually identifies them as a features to the respective target variable, or actually do they have the strong influence on target variable. And that's what the total number I don't want to give the customized number. I'll just go with the best one, whatever the best feature set that our backward selection algorithm will give us. That's more than enough for us. And then forward, so here if set to floating point value between 0 and 1, it selects the percentage of features to keep based on the total number of features. Okay, so then the next argument that we have here is forward. So this parameter controls the search direction. Setting forward equal to true enables forward selection where the features are added only by one. So setting forward is equals to false enables a backward selection where features are removed one by one. Okay, so that's what we have done. That's what is forward is. Next argument that we have here is scoring. So scoring, this parameter specifies the evaluation metric used to assess the performance of different feature subsets. So it can take various values depending on the task, such as accuracy it can take up this time, and precision it can take up, recall it can take up, F1 it can take up, so etc. In this in our code I have taken accuracy, so indicating that accuracy will be used as the evaluation criteria, but you can use any of them. It could be precision, recall, F1, or whatever you want. And then final argument that we have here is CV is equals to 4. So this parameter determines the number of folds in cross validation. So it specifies the number of subsets into which the data is divided for validation purpose during the feature selection process. So in this example, in our code, it's set to 4. It's set to 4, meaning a four-fold cross validation will be performed. So by setting these arguments appropriately, you can customize the behavior of sequential feature selector and the fine-tune the feature selection process based on your specified requirements. So now let's get back to the next step. So step 6, uh, once you have done the backward selection, then you can get the what all backward selection features has been given, or what all features were selected by the backward selection algorithm. Then you can take that X train and Y train so that you can put it in the model. So then we will evaluate the model. So evaluating the model here in this case, next we will be evaluating the model. Okay. Evaluate the performance of the model using appropriate evaluation metrics such as accuracy and recall and F1 score. Consider using the techniques like cross validation to obtain more reliable estimates of the model's performance. Then this is what we'll be doing. So we'll take that model, logistic regression model, and then we'll fit that model with selected features. And after that, we will evaluate the model's performance also. Then we'll print the accuracy, and this is what the final step. Of course, model selection has been done till this step, and whatever you do additionally is just closing up the, yeah, as you're finalizing the project and then deploying it into the real world environment. And let me show this evaluate the model steps also here. So we got the selected features here. The selected features are done. The next train selected, the next test selected, So then the most important step is to fit the model using the selected features, and that's what we'll be doing. So what is model object? Model object is nothing but your logistic regression object. Then I have used the fit method. I have called the fit method from the model object, and then I have my two arguments are xtrain selected, ytrain, xtrain selected, and ytrain. So that's it. And then finally we will calculate the accuracy. So accuracy, for that again you can call up the model, and you can call up the uh, method of the model, and you have to give the required arguments, which are x test selected and y test. So and finally you can print the accuracy, and that's what is our backward selection. And final step, interpret the results, analyze the selected features and their corresponding coefficients or importance scores from the model. So identifying the critical factors or features that contribute most significantly to the production of credit default. So that's what is our data set. And with this, it's almost all steps are done, and finally it's going to go for the deployment. So let's wrap this up by looking at the final step. Once all done, all set, let's evaluate the metric. And so from the model we'll be use score, and then we'll be calculating, and then get the feature names corresponding to the selected indices. So just that's it. Which all selected features has to be printed, and it should be converted into the list. And now let me execute the whole piece of code, and then let's see what's going to happen. So I got an accuracy of 0.78. It may not be too great, but it's not too bad also. It's okay. It's okay. On an average, closer to the point 8, but still it's fine. So now these are the selected features: age in years, employment in years, income in dollar, debt in dollar, credit score, loan amount, interest rate, etc., etc., etc. So that's what is our forward selection. Let me execute one more time so that you can clearly see here. So here I put the k best is let me copy this and execute the same code here so that I can just do minute tweakings here. Okay, let me give 3, and here you got the okay, but this time the accuracy is slightly better, 0.78. Nope, let me check the accuracy. No, accuracy remains same, 0.78, and here also 0.78. So age is years and employment in years and income. This makes more sense than any other. Look, okay, let me any other feature that it has. DP. So out of 1, 2, 3, 4, 5, 6, 7, out of the 7, so 3, even 3 together are giving best accuracy. If you see, age in years also affect your credit risk assessment, and then employment years and income. So that's what, if you want to make it I want 5, then in that case you can just make it to the 5, and let's see what magic is going to happen. And it's 0.7, still it's 0.7. Let me bring it down to the 1, and let's see what's going to happen. Okay, still it's 0.78. So let's go back to the work. Okay, so KP features is best, and what you got is maximum, whichever is best of the best worlds. Okay, that's how we do backward selection. That's it.